Okay, we're going to look at exponents. First, we're going to review some of the properties of exponents, and then we're going to work with them. So we want to explain why x to the m times x to the n is x to the m plus n. Well, if we look at it, x to the m would be x times x, and so on, m times. Then x to the n is x times x, and so on, n times. So if we put them all together, we have x times x times x times x, and so on, m plus n times. So that means if we write it in exponential form, we have x to the m times x to the n equals x to the m plus n. Now with this one, we're raising x to the m to a power. So we have x to the m times x to the m times x to the m times x to the m, and we're doing this n times. But really, x times x times x, m times x times x times x, m times x times x times x, m times, and we're doing this n times. So it's basically m plus m plus m plus m n times, which if we remember that multiplication is repeated addition, simply becomes m times n. So therefore, x to the m to the n becomes x to the m times n. Now the next one here we have xy times xy times xy, and so on, times xy, m times, which would be x times x times x times x, m times y times y times y times y, m times, which becomes x to the m, y to the m. So xy quantity to the m becomes x to the m, y to the m. You can basically distribute out the exponent. So we want to simplify this. Well, remember when you have square roots, you can multiply the radicands together. So it'd be 2 times 6 equals the square root of 12. However, 12 is the square root of 4 times 3, which we can break down to be square root of 4 times square root of 3. Square root of 4 is 2 times the square root of 3. So we basically multiplied the radicands together, then we separated the radicands. So here, we want to show that the square root of 7 plus, okay, we're not going to do this one. That's just too confusing and not something I'd ever ask you on a test. So we just won't do it. It's in the textbook if you want to see how it's done. This next one's more important to me. So we have 16 to the 3 halves. So we can do it as, we can break it down to be 16 to the 1 half to the 3rd power. Well, anything to a fractional exponent is a root. And because the denominator is 2, it's a square root. So this becomes the square root of 16 to the third. Square root of 16 is 4. 4 to the third, well, 4 times 4 is 16. And if we multiply 16 times 4, we get 64. Here we would have 27 to the 1/3 squared. So it's the cubed root of 27 squared. Well, the cubed root of 27 is 3, because 3 times 3 is 9, times 3 is 27. So this would be 3 squared, which is 9. Now, negative exponent, remember, means take the reciprocal. So this would be 1 over 16 to the 3/4, which is 1 over the 4th root of 16 cubed, which is 1 over 4th root of 16. Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So that becomes 2 to the third, which is 1 over 8. Same thing with the next one. This becomes 27. 1 over 27 to the 4/3, which is 1 over the cubed root of 27 to the 4th. Well, in the previous problem, we decided the cubed root of 27 was 3. So it's 1 over 3 to the 4th. So 3 to the 4th. 3 times 3 is 9. That's 2. Times another 3 is 27. That's 3. Times another 3 is 81. So that's 4. Now we have what appears to be a complicated one to simplify, but we're just going to use our rules of exponents. So the first thing, remember, we also work inside the parentheses. So the first thing, we're going to take care of this square in the numerator. So if we square everything, that means we multiply each exponent in the numerator by 2. So we have x to the negative 6, y to the 8th, over x to the negative 4, y to the 3rd, and the whole thing raised to the 2/5 power. Well, still, if we follow rules of operations, order of operations, we simplify what's within the parentheses first. Now, negative 4 is a higher exponent than negative 6. So we're going to move the negative 6 down and subtract it. So we have x to the negative 4 minus the negative 6. We're going to move the y to the 3rd up, which means we're going to subtract the exponent. So this gives us y to the 5th in the numerator, and negative 4 minus the negative 6 becomes x squared in the denominator. We have what's within the parentheses as simple as possible. So we're now going to distribute out the outer exponent. So in the numerator, we have y to the 5th to the 2/5 power. In the denominator, we have x squared to the 2/5 power. Well, 5 over 5 is 1, so this simply gives us y squared. and this becomes x to the 4/5. And that's it for this work. We are going to continue working with this in the next video.